Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be talking about this, the Odroid HC4, right after this. So the HC4 is basically a cloud designed appliance, and I guess maybe it would probably, in the old days we would call this a file server, or maybe it's a media server. But as you can see, it has two 3.5-inch cutouts for full-size hard drives here on the top. And then there's a fan on the side on this side, and then here there's your connectors. There's a 1 gigabit Ethernet port. There is a HDMI 2.0 connector here, a USB 2.0 connector here, and then there's an SD connector right here, and then a barrel connector for your power. And that accepts 15 volt 4 amps is what you need for that. And then, of course, there are two SATA connectors here on the top of the board. The processor, in true fashion, is mounted upside down, and there is a heat protector, heat spreader across the top of that. It comes in either 2 gig or 4 gig of RAM, and let's see, the processor is an Amlogic, and that is a S390 X3, or excuse me, 3905 X3. And according to the literature that Odroid produces, they claim that this runs at 1.8 gigahertz. However, in my testing, I'm seeing 2.0 gigahertz, a little bit over that, in fact. So they may have applied a slight overclock to this. I'm not sure, but we'll find that out when we're testing. There's two other unique factors on this particular design. First of all, it is based on the C4, if you're familiar with that Odroid. And that is also an Amlogic S3905X3 as well. But some of the unique features are, in the past, like the XU4 and the HC1, the HC2, those devices also allowed you to mount hard drives. Now, the XU4 had to use a special case, and it had an adapter that plugged into the USB 3. It was kind of a mess. But the HC1 and HC2 simplified that by attaching the drives to the sled and then having a massive power supply under it. But they could only handle one drive. The other problem with all three of those, the XU4, the HC1, and HC2, is they had to bridge the USB 3 to SATA in order to accomplish the connection to the SATA. This does not. This actually has a PCIe interface that drives the SATA ports. So, thinking maybe we'll see a little bit better performance than I have over the HC1 and HC2. At least I'm hoping that's the case, but don't know that. Won't know that till we test it. As far as the memory is concerned, it is 2133 megahertz equivalent, DDR4, and that's really about it. There are some other additional connectors on board here, like there's a UART, so that if you want to plug in for debugging information, you can do that. There's also a 5-pin interface that is for the OLED display. Now, originally, there were two models of this. This is the basic model, which doesn't have the OLED display, and then there was the Plus model, which did. I think the Plus model was so successful that they sold out of it, and I don't think there are any plans to produce any more. Don't know, maybe they'll change their mind, but right now that's what the notice says. There's no plans to make any more. I'm sure with user demand, though, being what it is, they might do that again. So if you want that, you can do that. You can have some information display here while the system is running. So the second thing I mentioned about this being unique, I'm going to set this down so I stop playing with it. The second thing that makes this unique is the boot structure. In the past, we've had to burn an image onto an SD card, plug the SD card in, and boot off of that. Now, Raspberry Pi made some inroads and changed some of that around so that now you can boot off of an external drive that's connected to the USB ports. But again, they're kind of back where the XU4 and the HC1 and HC2 were. They're still dependent upon the bus interface timings of USB 3 in order to provide performance for I/O. But this boot process is quite different. It's I wouldn't call it like a PC, but it has a multi-stage boot that is similar. So in this case, it goes through U-boot, which I think some of the older machines did too. I mean, I know U-boot's used on the HC4, or excuse me, the HC2 and the HC1, but there's now logic within the SPI that allows them to redirect that I/O depending upon what they find during the boot process. If they find an SD card, they boot from that. If they don't find anything at all, they'll present a menu and you can decide what you want to do. And one of those options is to Netboot. So, and there are two repositories which are up in the internet. And I don't know how many total there are, but there is one for Ubuntu and there's one for Debian. So if you don't want to install anything, you can just Netboot and go to those repositories and download those images and start running. That's what I'm going to do today. So let me get set up. I've got to connect all my connections. I'm going to be using, if I can find it, a Crucial 1 terabyte and I have found this Fire CUDA. It's a 1 terabyte. So I will be using these two drives. I'll be booting off of this one, and then I'll use this one as a data drive, and then we'll do some benchmark on it and see how it compares to some of the other benchmarks that I've already run. So I'll be back. Okay, I got my power connector, I got a keyboard, and I'm going to plug it in. Okay, so you'll notice right here that I have obviously installed this previously, and it sees that installed on the hard drive. So, but when I come up, I'm initially going to just get, if I don't have anything installed on the hard drives and I don't have anything in the SD card slot. So this is all I would get would be this menu right here. So if you want to get to the Netboot, you exit to the shell, you type in netboot _ default, and then exit. Well, maybe did I type it? Oh, I did. I typed that wrong, I think. Okay. And then it should, let's find out what's going on here. Of course, it's a demo, right? Pilot error. Let's try that again. Didn't have the Ethernet cord connected all the way in, so it was not active, and so it would not complete the operation. So once you return, you'll see if your Ethernet cable is plugged in correctly, you should see these two. So there's one for Ubuntu 2004. Now I tried this earlier with 2004, and maybe I did something wrong, but when I went to I just installed it as a base server, and it wasn't very stable. I started executing programs, and then it just went out to left field and never came back. So I ended up having to reboot it. So I'm going to try Buster. I tried that earlier, and it seemed to work just fine. So yeah, we're going to give that a shot. And down at the bottom, you should see booting complete, and then it'll start loading in different pieces of the bootloader. There's the image.gz, and now it's performing the actual startup. And it's taken me to kind of a standard install page. So we'll just walk through this. I'm going to put my mug back up here. And so, yeah, language, English, United States. Yep, keyboard, US. And then we'll wait. It's going to go try to find out what other hardware I have. A lot different than most of the ARM machines that I've dealt with. So this is much easier. So I just give it a name. This is fine. I don't need to give it a domain name, not for today. And then it's asking me what mirrors I want. So I'd like, yeah, obviously the ones in the US would be good. Get them as close to you as you possibly can, unless you like latency. Partition tool is loading up now, and it wants a root password, so I'll go ahead and do that. and then a name for the real user. And Central Time, good for me. Now we just sit and wait while it starts to bring down the partition map, and then it should come back and ask us what we want to do with the drives that it finds. And it should find both. I have both of them plugged in. So yeah, it found one drive at least. Don't know which one it is yet, but so you can boot things side by side here if you want on the same drive. I have not tried that, but it looks like you can. So I'm just going to do the entire drive. Yeah, I found them both. So I'll take the Crucial as my startup drive. And then you have some choices. These usually don't do things very well. So I guess probably if you really want to do these two options, go back and just set it up for manual partitioning. But for today, I'll just do them all in one. If you like its layout, then you can go ahead and confirm it. Now, it's not actually, well, it is going to put there is already an XFS partition on that drive, so it's not going to do anything new with it. So we'll go ahead and write them out to the SDA. It's not touching the SDB drive at all. Just to be clear about that. And now we wait. So I can sit here and watch it with you. It'll be a while. Even this takes some time, but those are 1 terabyte drives. So, and the processor is yeah. Well, I'll be back anyway, and we'll see how it does as I get closer to the end. It is. Looks like about 10 till 9 my time. So, yeah, we'll see how long this takes. Okay, it's been about 11 minutes or so up until this point. Of course, now the time that it takes you to install this will depend upon your network speeds. But it's asking me if I want to anonymously supply the developers with statistics about the most used tools. No, not really. And that's popularity contest, and yeah, we'll just turn that off. So now it's probably going to get ready and ask me what I want to install, and actually that's fine. I just want a server, right? If you want to put up, you find it. So if you want to put up a GUI, you can, but you'll probably need something like this, which is a USB hub, or you'll probably need a key, which allows for wireless mice and keyboards to be attached, because you only have one port. So I'm just going to go ahead and do a standard server installation and SSH server. That's fine. 102. Okay, well, it seems to be going pretty good. It's retrieving it anyway. Let's see how long it takes to actually install it. Yeah, I might be back. This might take a bit longer. I'll add it to the timer. So it's added about 4 minutes. Yeah, about 4 minutes on, so 14 minutes total. And now it's ready for me to remove the installation media. Okay. It's on the network. I don't think I want to remove the network, but it should then just flip back. You should see the hard kernel logo again, and then we should come back up into Petit boot. Now, according to the documentation, it says it is counting down. If you look in the bottom of the screen, booting in 4 seconds. So it says it will auto start without having to do anything. And yes, that is exactly what's happening. So it is doing what it said. All right, so well, let's see. What do I have here first? All right, so I'm not in the sudo group. That's a problem, but we could fix that. Let's see, what IP address am I on? Well, now that's interesting. It's picked up. It must not have found any DHCP addresses. It's been kind of an interesting night. So, okay. So anyway, we'll sort that out. But let's see. First thing I need to do is get over to root. And I want to add myself to sudo. Let's just make sure that I can do that. So far, so good. Yeah, all right. So I'll go sort out the network and I'll be back. I think we're finding some bugs. But anyway, I think I'm all set now. Yeah, I have an IP address. That's a good sign. So, all right. So let's do an update. Make sure that the cache is up to date. Should be, because it was performing the update as it was coming down. So, yeah. I think I want glances, neofetch, and git. Then I'll check and see if there's some compilers. IOZone, I'm probably going to have to compile, but that won't take too long. Okay, so I got all that done. Let me switch over to my other machine here, and we'll work. It'll be probably a little easier for you to see than off the console. We'll work off of the laptop. All right, so I am logged in. So the first thing I want to do is my usual. Let's take a look, and yeah, we're on a 5. Yeah, this is Debian. You're on a 5.9 kernel. So there is a PPA that is part of the package, the repos that is installed as part of the Netboot. So yeah, they're updating a lot of the packages to the latest releases, and so you are getting quite a few that you wouldn't get otherwise. And so let's take a look at an HTOP and see how much memory. So we're about 130 meg, and 23 tasks running, 4 threads, or excuse me. Yeah, 4 threads and only 1 is running, of course. And it's not much of a load because I don't have a whole lot installed on this either. So it's pretty bare bones. Let's take a look at how much disk space this is taking. About 1.3 gig, something like that. So yeah, and then we'll run neofetch just to see what it reports. So it is telling me I have 502 packages installed, and right here it is telling me the CPU is clocking in at 2.0. Now that's according to the proc file, and I don't know if that is correct or not. Since it says that it's supposed to run at 1.8, it's possible that it could be misrepresenting that, but we're using 134 meg of memory, of course, and according to this, well, let's see what the app cache is doing, and see what we get here. This will take a little while to come up. So yeah, so I do show 4 cores, and I'll just drop that back down and make it a little easier. 322 with the meg with the app cache. So it's not a tremendous amount of storage space that it is taking, and also not as very much memory it's taking either. Pretty good, actually, overall. Thermals are showing up, which is good. They're right here, 47C, 48C. That's well within the limits of throttling, but again, we're not really running anything either. So I'm going to go see if I can find a couple of benchmarks. I don't think sysbench is here, although that's really not going to overly tax this machine anyway. I probably ought to go get the byte benchmarks and drag them over. Those also require a recompile. So for this platform, I always want to make sure that I'm picking up the correct instruction set, because that does make a difference in the execution, along with the libraries as well. So I'll be back. I'll go set up a couple of things and we'll do a few benchmarks and just see how this is going. But before I go, the other thing, I've unplugged this drive. It's sitting right here in my hand. So I've taken this out. I want to see, it's supposed to hot swap. So I want to see if it'll do that. I'm going to place it in here. If it crashes, I guess we'll know that that was a bad thing to do, huh? Yeah, that looks right. There we go. Now see if it spins up. Yep, I hear it spinning up. And I see it. So hot swap is definitely part of the architecture. Now, I'm not going to try it the other way. But yeah, it does seem to hot swap. And all my devices are still there, so that's good. Let's see if I can mount it. Now that is an XFS. I shouldn't have to tell it that. Yep. Let's make sure I can write to it. Yep. Okay. Let's go ahead, and I have my DH4 benchmark here, and we'll go ahead and start that up. Now this is going to run against the SRV, which is this FireCUDA drive, so it's not, this isn't the SSD. We'll compare it, but this will be running on XFS. And then probably what I should do, just to make sure this is correct, is change it to ext4 and then rerun it. So I will do that too, just to see if there's any difference in it. So, and we'll go ahead and get this started. This will probably take some time to run. This, of course, does 5 iterations of all these tests. But right now, yeah, these are usually, now the writers are really moving. I mean, I can tell you that right now. But, you know, that cache is going to fill up, and then it's going to turn into a regular hard drive. So it's going to slow down. But I'll be back. So I wanted to copy off those results. And so this is the first pass with just a single user. And it, you know, it does pretty good up till about the second one. Then it starts to track off as we get to 2, 3, and 4. So, and rewrites kind of does the same thing. It starts tracking off though at 2 users, and then it just sort of craters. The read though is kind of telling. This is definitely showing that it's kind of out of the cache and it's onto the actual hard drive, because you see this huge drop in performance. Picks up a little bit, but doesn't really regain to the original. And same thing here, same thing there, same thing there. Yeah, this one picked up speed on the mixed workload until it gets out to the higher number of users. So this sort of scaled up. And then the random write kind of goes up and down like a yo-yo, which is kind of typical with that. The p-write, and yeah, that kind of trails off. This one really craters on the p-read. Looks like the reader's really having a trouble with that drive. And so the writing is okay on it, but reading not so well. Probably not a real good candidate. I mean, it is a hard drive, so yeah, it's not a real good candidate to be used as a media drive, but yeah, it'd probably be okay for a file server drive. F-write, yeah, it goes up to the second user, then kind of dies, and then the same thing here. Goes up and up and up and up. The F-read does actually pretty well. It just inverts what the kind of performance up here is. It kind of does better and better, and a little bit better, and then a lot better. So I also ran this on a Raspberry Pi. I have this one. This one is set up with a SanDisk SSD Plus. I think it's a 512 gig. And this one is channeled, it has the operating system installed on it and is running off of the SSD. And so that is, we can probably go look and see. Let's see, it is a EXT4. It's an EXT4. So let's see how the SSD did. Now this is using the USB bridge to SATA. And so, yeah, this is, it gets up to 3 and then it kind of trails off. It does the same thing here. This one gets a little better all the way through on the read. The reread kind of trails off a little bit and then picks up again. Reverse read does quite well, actually, and then it kind of dies off at the 5. Random reads. Actually, I mean, that's probably, once this settles down pretty well, it loses a little bit of steam, but it kind of settles down in the 3 and 4. Mixed workloads, doing quite well. Now, what I need to do is let's see, we go up and then down, then back up. This is kind of a yo-yo. This one goes steadily down. F right goes steadily down. F read picks up speed. So I think what I'll do is let me now I'm back on, this is the Debian box. This is on the HC4. So let me unmount SRV. Make sure that it's off. Okay. And then I think what I'll do, did I capture the results here? No, I didn't. So I want to keep that. I'll probably make a graph out of this at some point, and this is XLS. Yeah. Let me just make sure I've got them. Okay. I'll get it in a minute. Okay, and we'll go ahead and this time it'll run off the Crucial. This is the boot drive. You can already tell it's a lot quicker. So I'll be back when this is done, and we'll kind of compare the results between this one, which is using the PCIe backbone for its SATA, versus the USB 3 on the Pi. Okay, so I want to copy that result off before I lose it. And this is the Crucial EXT4. And let's take a look and see how it compares. So the Pi is right here. Yeah. Now the characteristics of these two drives is only slightly different. I mean, as far as their read and write speed, the Crucial and the SanDisk are pretty close. I mean, they're not this far apart. So yeah, you can see that we definitely have some differences. If you look down the first column here down to P-read, and yeah, it is definitely performing a lot better over on the PCIe based one. So I need to run one more benchmark, and that is to put the FireCuda back up and run it as EXT4. And so I will do that, but it's pretty clear to me that yeah, the Pi just kind of doesn't quite keep up. It's I would say at least half the speed going through the USB 3, which, yeah, that's a pretty terrible interface to use to hook up a drive. You lose an awful lot. As far as the drive performance is concerned, once you get up into these numbers, it's getting pretty close, to the cap of the drive. I mean, yeah, I mean, this is buffered down here. That's why it's so ridiculously large. So a lot of this is buffered in memory. So that's just the way F reads and F writes work. So it buffers them up, and then it floods the drive with them, with the I/O. So, yeah, I don't think there's much discussion here. USB interfaces to SATA controllers, bad, really bad. But I'm sure at some point, you know, at the rate that the SBCs are improving in the I/O performance, Odroid definitely has a leg up on the Raspberry Pi. I'm going to assume that I'm going to see pretty similar results with the HC2 and the HC1 that are currently running in my Gluster cluster, and I probably will be switching over to this machine for a couple of reasons. One is it gives me some extra drives that I can mirror, and that should give me a little bit more read performance. Now, of course, it's not going to help write performance, but it will help read. So let me set up. I'll be right back. I need to set up and get the drive mounted again, and then I'll format it and let you guys watch the results get started. Okay, so I've tested the mount, and now I'm gonna make it an ext4. I just want to make sure it's still online, didn't go to sleep for some reason. So I'm just gonna check this again. So this is a make file system ext4 device SDB1. Be careful which drive you grab. Yeah, and yes, we want to proceed anyway. So I know I got the right one. It says it's XFS. So we'll go ahead and do that. Yeah, this is a good, if you want to, besides disk destroyer, this is another good way to destroy your boot drive. So we'll go ahead and mount it. And it's mounted, and we'll go ahead and start DH4 up. And I'll be back when that's done. Yes, it always starts out really well, doesn't it? And then it'll die once we get past a few of those iterations. But yeah, I'll be back. Okay, so what I'm going to have to do is compare this to the Raspberry Pi one. Friday, what I'll do is I'll graph all these out and then show you the result. But this is kind of interesting. So we start out about the same as an SSD, and then of course it drops off, which is what I said it would do. Doesn't quite get the performance up, and then it kind of dies. Yeah, it turns into a hard drive around here, around the two users. So hybrid drives like the FireCuda, and of course they do have, Seagate does have a FireCuda that's an NVMe now. So this is an older one, and it was a hybrid, what they consider a hybrid drive. So like I said, it's not great, but for a single user, it's probably okay. I mean, it's not it's not wonderful, but it isn't terrible either. I mean, for a single user, it'd be all right until you started doing compiles, and then it would be back to a normal hard drive. So yeah. So what else can we say about, let me close out the Pi. I think we're done with that for now. Let me just make sure I save that. So I know what it is. And then I'll save this one too. And this is a FireCuda ext4. Okay, got it. So I guess and now we'll go ahead and just get rid of that. We don't need to do anything with that anymore. Or this. And we'll go ahead and look at a few other things. So I'll go out here to opt, and I'll put out glances. I do have get, I hope. Yeah. It's getting late. Yeah, we'll go ahead and clone this out. Typically, Debian will take a little longer. Oops, I should tell it what I want it to do. And typically Debian will take a little bit more work, and because in this case I installed a minimal system, so a lot of the packages that you would normally get on a desktop aren't here. And so I'm sure it will flag all the stuff that's missing and say, hey, you need to install some stuff. Yeah, I'm seeing a lot of suggestions, a lot of stuff that's disabled. I probably also put up NFS on this as a server and maybe retest with that too. Of course, that's going to be over a network then. But, while this is going through, overall, this is a $65 device for a 4 gig. And it'll probably cost you another $10 for the power supply. You don't need an SSD, but if you need an SSD or a hard drive, then you have to add the cost of that unless you already have one that you can use. One of the things I will say is that for the money, you could buy an old x86 machine and put it together, but what you're left with is an old x86 machine that probably has vulnerabilities in the firmware. Intel didn't go back and fix a lot of those, and so you probably are running a machine that has firmware that is probably has a potential to have malware inserted into it. But anyway, you could do that, and that is an option. It's up to you. I'm certainly not telling you what to do, but if you're looking for a cheap storage device that you want to put 2 drives on it, and this will run it will run media servers in Linux. Kodi is one of them. Electric is it? Yeah, Electric, is that the other one? Electra. I don't know. I don't use those. I use Emby. Emby does run on those as well. I haven't tried it yet to see what it does with transcoding. So it's not a bad machine at all. And the Raspberry Pi is going to be a little cheaper at 4 gig. I think they're $50, $55, somewhere in there. And then, of course, you can get that one in 8 gig. This one doesn't come in 8 gig. But it's a duh that having and somebody's going to say, well, yeah, of course PCIe is faster. That's not always the case. Just because the channel speed is faster doesn't mean the processor can feed it fast enough to keep up with it. So, and you run into a situation where you get starvation on the channel. And the performance here that I'm seeing isn't indicating that there's any starvation on the channel. It does indicate there's contention for the drive, and that's fine. That's what we want. We can deal with that problem by adding additional drives and making sure that the writes are ping-ponging between both of them. That will cut down some of the contention. Let's see, what else can I say about it? So, 62 score. Yeah, all the typical stuff. We need to set up our SSH configuration to make it hardened. Need to set up a firewall. I'm curious if it's flagging this for. Usually, on ARM processors, I can't find the boot file, and this is not having that problem. So that's good. Usually, it can't find the image of the operating system, and it's like, where is it? I can't find it. So yeah, it's finding it. That's good. Either they patched this or the fact that, let's see, it's probably in boot. Oh, it's there. Yeah, the VMZ Linux is there. Usually, it's looking for that one, looking for that linkage, and if it doesn't find it, it throws a fit. But yeah, 62. Okay, I'll buy that for a server build, and yeah, I'll have to do some work to harden it, but that's not too bad. I'm going to put this into use as a file server initially, and then I'll probably try some media services with it as well. I do have one thing I want to test before I go, and that is, let me get out of this. I want to try the just make sure that this is disconnected. Okay. And then I'm going to try to yank the drive out and see if it crashes the box. because it is supposed to be hot swap. There's the drive. I just yanked it. Now, unfortunately, this case, I pulled that out with it spinning. So I pulled it up first and kind of held it steady and then dropped it. I don't have a door. Normally, you would have a door that would kind of hold it there for a minute, let the drive spin down so the heads didn't skip across the platter. So it's a good way to get a head crash. With an SSD, of course, you wouldn't have that problem, but I am still running. It did take the drive away. So I guess that's good. I don't care about this drive. It's an old one, and the aging on this drive is coming up to the point where it's about to fail. This one was in my Proxmox server for a long time, and it was my backup drive. So the number of boots and the number of accesses were in the hundreds of thousands on this drive, so it's probably about ready to be replaced anyway. But yeah, so hot swap will work. I don't recommend doing what I just did. Take the chance on crash on the heads. But yeah, so I think that's all. That's where I'm going to stop today. Like I said, I promise I'll get these published and get some graphs up so that you guys can take a look at those. I was watching the Apple announcements today, and I always think it's funny when marketing talks about performance. 11 trillion operations per second. Let me tell you something. There's no way that they're trying to make you think it's a supercomputer. NVIDIA did the same stuff with their announcement of their graphics cards, and then you go read the fine print and it's integer. Supercomputers, when they do the number of teraflops are calculated based on either single or double precision floating point numbers, which would either be 64-bit or 128-bit. Typically, the marketing guys, they'll use integer, which is 8-bit. So it's apples and oranges and not the same thing. So yeah. Anyway, be careful of what you hear. They're trying to make you think that it's a supercomputer. I guarantee you it isn't. But it is good to see that these smaller processors are starting to pick up in their performance curve. I don't know what the CPU performance on this is. I promise when I come back Friday, I'll have those numbers. Like I said, I've got to compile the benchmarks and run the CPU against it. And this is similar to the C4, so I'm going to bet it's probably close to any benchmarks that you've probably seen on the C4. Although it is overclocked slightly. Anyway, that's all I had. Enough for now. I hope you enjoyed this video. If you did, please like and subscribe. And if you do want to support the channel, either join it or go to my Patreon page and join there. I'm gonna try to get it organized a little bit better so that I'm publishing my videos out a week ahead of time up on Patreon. So then you can watch them there without having to watch the ads. Hopefully that will help. Take care. See you all later, and bye for now.